Station 5 talks about systems of linear equations and linear inequalities. This is a huge topic that we only spent a couple of days on, so it's really important that you review it thoroughly. I wanted to start with just what is a solution to a system. Some of you may need to back up even further than that and understand what is a system. A system means that there is more than one equation or more than one inequality. So you'll notice in my pictures down here, most of them include two lines or two lines and two groups of shading. Let's just go over the type of solutions you could find. For a system of equations, we're graphing two different lines. So their possible solutions are in these first three. On the very first one, you can see that there are two lines and they cross or intersect at a point. When you look for that point where they intersect, you're going to find that in this one it's in the positive quadrant and it looks like it's about 1, 1. I'm not specifically trying to teach you about this problem. I just want you to understand that when you do have a solution, it's an ordered pair. And so it's important that you write it in that format. If you have one line that falls directly on top of another, you'll get an infinite solution set, or we said infinitely many solutions. That means that the line crosses at every single point on the graph. Here, 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 and I could keep going and going and going on that one. As you can hear, someone is really trying to call me. I apologize for the inconvenience. If I have two lines that are parallel, that means they will never, ever, ever cross. So there is no solution. So we called this one solution infinitely many and none. Those were the three possibilities for equations, systems of equations problems. If we're talking about inequalities, we have two different scenarios that can happen. I'm going to graph each of the lines. Remember, you have to think about, is it a solid line? Is it a dotted line? Do I shade above or do I shade below? And all of that's important. We'll review it in a moment. But in general, when I try to find a solution of one of these guys, what I'm going to do is I'm going to do all of those pieces. I'm going to shade, and then I'm going to look for the darkest section, the one where there's double shading, and that's where my solutions are. In this example, I have two parallel lines, so it's much like this one over here, except now I also have shading. The shading is in opposite directions, so that means there are no solutions here. And that's a specific case that happens, but there isn't any overlap, and that's why I'm not going to be able to find a solution. Overall, you may be given a graph and asked what kind of solutions there are, or more likely you're going to be given an ordered pair, an x, y, and the way you need to figure out if it's a solution or not is to plug it in and check your work. So I've given you an example like that, and you have some on your review. That's what the final exam is going to be like as well. So in this case, I have the system 8 minus x is less than 2y, and 3y plus 1 is greater than or equal to 4x. And I'm noticing that my Zoom is not great. Again, guys, I am not a professional videographer, so you'll just have to hang with me on that. You can see this first linear inequality, and I chose inequalities because I think that's probably the one you need more help with, but an equation would be done the same way. I'm going to take this first inequality, 8 minus something is less than 2 times something. I know that x and y are the somethings, so where I had an x, I'm going to replace it with 0. Where I had a y, I'm going to replace it with 1. And then I need to carry out that operation. So 8 minus 0 is 8, is less than 2 times 1, which is 2. Is 8 less than 2? No, it's not. So normally, I would check this one as well, but because I know that this is not a solution, it's not even a solution to the first one, it's definitely not a solution to both, and I can stop right there. 0, 1 is not part of the shaded region of these two inequalities. If I had put it on a graph by putting it into y equals format, I would see that this is in one of these regions. I'm not going to test the second one, but I know that it's not in both. So that's a little bit about solutions. The next thing that I want to address is how to solve a linear equation. So if I have a system of linear equations, again, that means I have two of them. The only way we've learned to do this so far is by graphing. And specifically, we practice this the most in your calculator. So I've got y equals x plus 2. That one's already in a perfect format for me to put in my calculator. And I have 3x minus y equals 8. That's not in such a good format. I need to solve that for y. Remember, to solve, I'm going to use my inverses. So I've got to move the x over first. When we did this originally, we drew the line down. Some of you got more comfortable and were able to move on without the line. Some of you still need it, so that's a personal preference. I bring down the negative y, and I see students make this mistake a lot. They forget to bring down the negative. It's really important that you don't just drop that guy. Then to get rid of the negative 1 that's in front of y, I can either multiply by negative 1, divide by negative 1, or do my favorite, which is flip every single sign. Now I've got two equations in y equals format, and to find their solution, I can go to my calculator. If something's already in y equals, you can just clear that on out. I'm going to put my first equation, x plus 2, and my second equation, 3x minus 8, and I'm going to graph them. Hopefully they'll be in the screen, but you'll remember that if they're not, we can always zoom out using the zoom function on our calculator. After we've done that, the buttons we need are second and trace. And I think from there you'll remember what to do. Second, trace, and we're looking for the intersection. So we use that number 5. We scroll over as close as we can to the actual intersection and hit enter 3 times. You will see that we are given the solution by our calculator, and that solution is 5, 7. We write it as an ordered pair and we're done. The last thing I want to discuss with you on this station is inequalities, particularly remembering the rules. And this is something that there really isn't a trick for. You just have to memorize what's happening here. I made this chart for you because I think if you can remember these rules, you'll be fine on this part. Let's just go over it real quickly. If I'm looking at a solid line, it has a line underneath. If I'm looking at a dashed or dotted line, it does not have a line underneath. Now look at it from the other perspective, the one about shading. If it's greater than or equal to, and I pointed the wrong direction, excuse me, greater than or equal to or greater than, that means I'm going to shade above. Think about that. Above means greater. Above means more. Greater means more. That should really kind of be able to stick in your head that way. If I have less than or equal to or less than, I'm going to shade below, because below means not as much, just like less means not as much. When I go to write the linear inequality, I want to write it in slope-intercept form, because that's the easiest way to write a line. I'm going to start by looking at my y-intercept, which is negative 3, and I'm going to put that in the b position. And then I need to pick another point to be able to calculate my slope. I'm picking a point right here because I can see that that's where it goes through the graph. And I'm going to calculate the slope by counting my rise over run. I go up 3 and over 2. And so my slope is 3 over 2 times x. The last thing I need to do is decide about my inequality sign. I can see that it is dotted, so it's either greater than or less than. And I can see that if I had a person climbing this mountain, they'd be on the top side, which means I shaded below. That means I need a less than symbol. And if you were to do a system of linear inequalities, you would have a second graph that you would also write an equation for. Hope this has helped you remember all the things that we learned about systems.